Download this code from codegive.com, link in the description below. OK, let's dive into Dave Farley's argument against extensive end-to-end, e2e, testing and how to approach testing in a more effective way, as discussed in his goto 2023 talk, and related materials. I'll explain the reasoning, the alternatives he proposes, and provide code examples to illustrate the concepts. Understanding the core argument, the fragility and cost of end-to-end tests. Dave Farley, a prominent figure in continuous delivery and software development, argues that relying heavily on end-to-end, e2e, tests as the primary verification mechanism is a flawed strategy. His main points can be summarized as fragility e2e tests tend to be brittle. A small change in one part of the system can cause a cascade of failures in e2e tests that are testing completely unrelated functionality. This is because e2e tests exercise a complex system with many moving parts. A failure doesn't necessarily indicate a problem with the code being tested by that particular e2e test. It could be a dependency, infrastructure issue, or a slight UI change. High maintenance cost because of their fragility, e2e tests require a significant amount of maintenance. Every minor change, even those unrelated to the core logic, can lead to test failures and require updating the tests. This consumes valuable developer time. Slow feedback loops e2e tests are typically slow to execute. Running a full suite of e2e tests can take a long time, minutes, or even hours. This slow feedback loop makes it difficult for developers to quickly identify and fix bugs. This significantly slows down the development process. Difficulty in debugging when an e2e test fails, it can be challenging to pinpoint the root cause. Because the test covers the entire system, the failure could originate in any of the components involved. Not a great return on investment given their fragility, high maintenance cost, and slow feedback loops. E2e tests often provide a poor return on investment in terms of the confidence they provide compared to the resources required to create and maintain them. E2e tests are a poor substitute for good design. Over-reliance on e2e tests often masks underlying design flaws. A complex, poorly designed system will be difficult to test, and e2e tests will be especially brittle. The focus should be on creating well-decomposed, modular code that can be tested in isolation. Farley's alternative, test pyramid and component-level testing. Farley champions the testing pyramid, a concept popularized by Mike Cohn. The testing pyramid advocates for a greater emphasis on lower-level tests, unit tests and component/integration tests, and a smaller number of high-level, e2e, tests. Unit tests These tests focus on individual units of code, functions, classes, methods, in isolation. They should be fast, deterministic, and provide fine-grained feedback. Component/integration tests These tests verify the interactions between different components or modules within the system. They are more comprehensive than unit tests but still more focused than e2e tests. End-to-end tests These tests exercise the entire system from the user's perspective. They should be used to verify the most critical user flows and system integrations. They are not meant to cover every possible scenario. The key shift: focus on building testable components. The most important takeaway is that rather than relying on e2e tests to discover bugs, focus on preventing bugs by building well-designed, testable components. This means decomposition and modularity break down the system into smaller, independent components. Clear interfaces define clear interfaces between components to reduce dependencies. Asterisk dependency injection. Asterisk use dependency injection to make it easier to mock and stub dependencies during testing. Asterisk single responsibility principle. Asterisk each component should have a single, well-defined responsibility. Practical examples with code, Python. Let's illustrate these concepts with a simplified example, an online ordering system. Scenario asterisk a user places an order for a product. The system needs to 1. Verify product availability. 2. Calculate the total price, including taxes and discounts. 3. Process the payment. 4. Send a confirmation email. Poor approach, over-reliance on e2e tests. Problems with the e2e test above asterisk. Asterisk extremely slow. Asterisk involves launching a browser, navigating through the UI, filling out forms, and waiting for elements to load. Asterisk brittle. Asterisk any change to the UI, example changing the ID of a button, moving a form field, will break the test. Asterisk difficult to debug. Asterisk if the test fails, it's hard to know exactly where the problem lies, product availability, pricing, payment processing, email sending. Asterisk requires external dependencies. Asterisk requires a web browser, example Chrome, and its corresponding driver. Better approach, component level testing with unit tests. First, let's define the components. Now, let's write unit tests for each component. Explanation of improvements. Asterisk unit tests for each component. We have separate unit tests for the inventory service, pricing service, Stripe payment gateway, and notification service. These tests are fast, deterministic, and easy to debug. They focus on the specific logic of each component. Mocks and stubs. We use unitest.mock to create mock objects for the dependencies of the order processing test. This allows us to isolate the order processing logic and test it independently of the actual services. We configure the mocks to return specific values, allowing us to simulate different scenarios, example successful payment, failed payment, product not available. Component test for order processing. The test order processing is a component level test that integrates the various services. It verifies that the services are called in the correct order and with the correct arguments. We don't need to test every possible scenario here. We focus on the happy path and a few critical error cases. Dependency injection. The order processing class, which I've only simulated in the test, would need to take the services as dependencies, injected via its constructor. This makes it easier to mock them during testing. Focus on verifying interactions. The key to testing with mocks is to verify that the mocks are called with the correct arguments. This ensures that the order processing logic is interacting with the dependencies correctly. When e2e tests are still important. Farley doesn't advocate for eliminating e2e tests entirely. They still have a place in the testing strategy. Critical user flows. E2e tests are valuable for verifying the most critical user flows, example placing an order, creating an account, logging in. These are the paths that are most important to the business. System integrations. E2e tests can be used to verify that the system integrates correctly with external systems, example payment gateways, shipping providers. Regression testing. E2e tests can be run as part of a regression testing suite to ensure that new changes haven't broken existing functionality. Smoke tests. A small suite of e2e tests can be used as smoke tests to quickly verify that the system is up and running after a deployment. Guidelines for writing effective e2e tests. Keep them minimal. E2e tests should be as short and simple as possible. Avoid testing every possible scenario. Focus on business value. E2e tests should focus on the features that provide the most business value. Make them resilient. Use techniques to make E2e tests more resilient to UI changes, example using semantic selectors, avoiding brittle locators. Run them less frequently. E2e tests should be run less frequently than unit tests and component tests. They can be run as part of a nightly build or before a release. Use data setup carefully. Data setup for E2e tests can be complex. Consider using database seeding or APIs to create test data. Avoid hard-coding data in the tests. Test against a staging environment. Whenever possible, run E2e tests against a staging environment that is as close to production as possible. Key takeaways from Dave Farley's argument. 1. Prioritize unit and component tests. Invest heavily in writing comprehensive unit and component tests. 2. Design for testability. Design your system to be easily testable. Break it down into smaller, independent components with clear interfaces. 3. Use E2e tests sparingly. Use E2e tests to verify critical user flows and system integrations, but don't rely on them as the primary verification mechanism. 4. Embrace the test pyramid. Follow the testing pyramid, with a large base of unit tests, a smaller layer of component tests, and a thin layer of E2e tests. 5. Focus on preventing bugs. The goal is to prevent bugs from reaching production in the first place. This is achieved by writing high-quality code and comprehensive unit and component tests. 6. Consider contract tests. For integration between services, especially microservices, consider contract tests, example using pact, to ensure that the services are compatible. This is especially important when different teams are responsible for different services. By following these principles, you can create a more robust and maintainable testing strategy that provides better value and faster feedback. You'll spend less time fixing broken E2e tests and more time building valuable features. Remember, the goal isn't to do E2e tests, it's to verify the behavior of your system. And well-designed, well-tested components provide more reliable verification with less effort than a fragile web of E2e tests.